Okay, so what if I told you there's a scientific paper out there that claims to be a complete, honest to goodness engineering blueprint for controlling reality itself? I know, it sounds wild, but we're about to dive deep into this incredibly audacious document, which presents itself as not just some abstract theory, but a literal user manual for the entire universe.
I mean, this quote from the paper's conclusion, it really just says it all, doesn't it? We are not talking about making a few small tweaks here and there. We're talking about getting full-on system administrator access to the universe itself. So, the big question is, how on earth does it claim we can do that?
All right, so here's the game plan. We're going to start with the huge overarching idea behind this so-called user manual. Then we'll see how it supposedly solves one of the biggest mysteries in all of physics. From there, we'll get into the hardware, the ultimate microchip designed to run it all. And then the fun part, exploring the insane applications, figuring out where all the power comes from. And finally, we'll land on the most important part, the reality check. How could any of this actually be proven?
Okay, let's dive right in. The core concept is called the Total Information Fidelity Specification, or TIFS for short. And the central idea here is, well, it's a huge shift in perspective. It asks us to stop thinking about the universe as just a bunch of physical objects, and instead see it as a system of controllable information.
Think about it like this. Imagine our reality is a super advanced video game. All we ever see is the final rendered image on our screens, right? But TIFS claims it gives us access to the source code, all the unrendered information humming along in the background. The paper calls this background layer the plenum. And here's the kicker. This isn't presented as some philosophical thought experiment. It's laid out as a closed, buildable system, something we can actually engineer. Any theory this big, well, it needs an equally big problem to solve, right? It has to prove its worth. And for TIFS, that problem is one of the deepest, most baffling mysteries in all of modern physics, the cosmological constant problem. So to give you a little perspective here, our best series, the ones that work incredibly well for everything else, predict that empty space should be just fizzing with a colossal amount of energy. But when we actually go out and measure it, the real value is 120 orders of magnitude smaller. We're talking a 1 followed by 120 zeros. I mean, this isn't just a rounding error. It is, without a doubt, the single worst theoretical prediction in the entire history of physics.
So, how does TFS even begin to explain this away? Well, it proposes a really radical shift in how we think about it. It says, what if vacuum energy isn't some fixed static number? What if, instead, it's available bandwidth, a dynamic, controllable resource that's just sitting there in that underlying informational layer, the plenum? In other words, all that predicted energy is there. It just hasn't been rendered into our reality yet. And this is where we get to the real engine of the whole system, something called the actualization operator. This is the core of it all. Just think of it like the specific command or the function call in the code that allows us to tap into all that unrendered bandwidth and actualize it, basically turning that dormant information into real, tangible, physical effects right here in our world.
Okay, so we've got the theory, but how do you go from pure math to actual physical hardware, right? If the actualization operator is the software, then what's the microchip you're supposed to run it on?
Well, the paper gets very specific. It lays out the plans for a seriously exotic piece of hardware. It starts with a sheet of graphene, but it's not just any graphene. It has to be made of isotopically pure carbon-12, which means every single carbon atom is identical. And then it gets co-doped with a precise pattern of lithium and nitrogen atoms. This whole unique material is engineered to be the physical interface. It's the keyboard and mouse for talking to that deeper level of reality.
And the level of engineering detail here is just incredible. That carbon-12 purity, that's there to eliminate all the quantum noise from the spin of atomic nuclei, so you get a clean signal. The specific way the lithium and nitrogen atoms are arranged, that creates a synthetic magnetic field that's way more powerful than anything you could get normally. And to top it off, there's a special fractal pattern etched right into the graphene that acts like a funnel, concentrating energy with unbelievable efficiency. So what's the end result of all this crazy engineering? Get this. The lattice can produce an effective negative energy density of 10 to the power of 22 joules per cubic meter. Now, let's be clear. Negative energy is one of those holy grails of theoretical physics. It's the stuff that would allow for things we've always thought were impossible. And this device claims to actually generate it. Why is that a huge deal? Because this kind of macroscopic negative energy is exactly what physicists think you would need to build something like a stable, traversable wormhole.
So we have the theory, and we have the hardware.
Now for the big question. What can you actually do with it? And this is where things go from mind-bending to truly world-changing. First on the list is something called universal remediation. The core idea is simple. A particle is just a packet of information. TIPS claims it can access that packet and just reindex it. So imagine pointing a device at a pile of radioactive waste and rewriting the strontium atoms to become stable zirconium atoms. Poof, gone. Or taking waste carbon from the atmosphere and turning it directly into useful graphene. It's not a chemical reaction, it's an information update.
And then there's the big one, non-local transit. Yeah, we're talking wormholes. The paper lays out a clear step-by-step protocol. First, a probe sets up an entanglement link. That's the hook. And this is absolutely crucial. The system is designed to protect causality, meaning no new information can be sent faster than light. Once that link is stable, the system just relocates an object's entire quantum wave function to the pre-established address. And the predicted travel time for a 4.3 light-year trip to our nearest star system? Just under half a millisecond.
Okay, but wait a minute. A question should be screaming in your head right now. Where in the universe do you get the gargantuan amount of energy needed to pull off these cosmic-level feats? Well, according to the paper, the answer is right in our backyard, our very own sun.
The plan calls for a massive orbital power grid, basically a constellation of 12 500-kilogram buoys. They'd be positioned out at the Sun-Earth L4 and L5 Lagrange points. These are super stable spots in space where gravity kind of cancels out. And these aren't just solar panels. They're designed to actually exploit the sun's gravity, the curvature of space-time itself, to amplify their energy harvesting. Oh, and the whole system is built with redundancy. Get this. Just 3 of the 12 buoys are enough to sustain a full-scale wormhole event.
And the numbers here really give this a serious air of engineering credibility. Each one of those buoys can generate 150 kilowatts continuously. That's enough to power about 150 homes. The whole constellation working together, that's a steady output of over 1.8 megawatts. But when it's time to open a wormhole, it can unleash a peak power burst in the gigawatt class. We're talking the output of a large nuclear power plant, all focused in an instant. And you can really see the scale of that power here. The collective output of the entire constellation creates this immense, continuous source of energy, just waiting to be channeled on demand for any of these, well, reality-bending applications.
Okay, I know, this all sounds like something straight out of science fiction, which is why we have to end on what is by far the most important section, the reality check. How on earth could you ever even begin to test a theory this massive? Well, for starters, the paper anticipates all the big scientific objections you'd expect and claims to resolve every single one of them. Worried about violating causality and sending signals back in time? It claims the system is designed to prevent that. Concerns about energy conservation, quantum decoherence, scalability? For each one, the TIFS framework provides an internally consistent answer. But this right here is the most crucial point in the entire paper. For all its cosmic, reality-shattering claims, the entire theory is falsifiable. It all comes down to a single, achievable, tabletop experiment. You'd use a well-known technique called Ramsey interferometry to test just a 1 centimeter square piece of this special lattice, and you'd look for a tiny, very specific predicted phase shift. If that shift is there, the theory is on solid ground. And if it's not, the whole thing falls apart. It's that simple. And that just leaves us with a pretty mind-blowing final thought. This document doesn't just describe a universe to be observed, but one to be actively engineered. It draws a direct line from a simple experiment you could do in a lab to the most profound technologies we could possibly imagine. So the question isn't just, is it real? It's, if a simple tabletop experiment could unlock the entire source code of the universe, what would we do first?